All right, folks, what I want to do here is I want to show you how you can use information from megatable to be able to write the equation of a line tangent to the graph of a function, okay? So you remember megatable, we have all of our x inputs up here, and then we have the function f of x. These are all the output values of f of x. And then we have its derivative f prime of x and all of the outputs for f prime of x. And so let's say that I wanted to answer a question about the equation of a line tangent to f of x. Let's say we said, what is the equation of the line tangent to f of x where x is equal to 2, let's say. Yeah, no, let's not do 2. Let's do 1, where x is equal to 1, okay? Equation of the line tangent to the graph. And so I want to remind you that if you wanted to write the equation of a line in point-slope form, right? Point-slope form, write it over here, point-slope form of a line is y minus y1 is equal to slope times x minus x1. And that all you need to write the equation of a line in point-slope form is you just need a point x1, y1, right? So as long as we have an x value and then a y value, right? x1, this is a comma, x1 and y1, and then you have a slope, m. As long as you have these three pieces of information, an x value, a y value, and a slope for the function, you can write the equation of a line, okay? And so this now becomes a very simple process when we're already given all of the information. So if the question is, so what is the equation of the line tangent to f of x where x is equal to 1, all we have to do is go to f of x, which is the first row, where x is equal to 1 is right here. And so we already have an x value. So our x1 is actually equal to 1, because that's what's given to us. Okay, and you have to be given at least one piece of information in order to get the other two pieces of information. So now what is the y output value that goes along with the input of 1? Okay, so what we're essentially looking for here is what is f of 1? Well, f of x is along this row, and 1, the output value is -7. So y is -7, right? And now all we need is the slope of f of x at the point 1 and -7. Well, we've already said that the slope comes from the derivative, f prime. So all we need is f prime of 1. So here's f prime, the second row, and we go to where x is equal to 1, and we can see that the derivative is equal to 3. That means that the slope of f of x where x is equal to 1 is 3. And so now all we have to do is plug this 1 and this -7 and this 3 into the point slope form, and we get y. Now it'll be minus -7, but that'll become +7. So y plus 7 is equal to slope, which is 3, times x minus the x value that we plugged in is 1. X minus 1. And so we have y plus 7 is equal to 3 times x minus 1. And so this is the equation of the line tangent to f of x when x is equal to 1. Okay? Let's do another example. All right, so let's try this one. This one says, what is the equation of the line tangent to g of x where x is equal to -4? Okay? All right, so again, we just need three pieces of information. They've given us the x value. So x1, for the purposes of that formula, is -4. We just need the y value. So we need to go where x is equal to -4. That's right here. We just need the output value for g of x, which is 3. G of x output is 3. That means y is equal to 3. And now we just need the slope, and the slope is going to be where g prime of x is equal to negative 4. Or where we plug negative 4 into g prime of x. So g prime of negative 4 is negative 6, and so the slope is negative 6, and therefore the equation of our line is going to be y minus 3 is equal to the slope, negative 6, times x minus negative 4. Now x minus negative 4 is going to become x plus 4. So x plus 4, and then here is the equation of the line tangent to g of x, where x is equal to negative 4. Okay? Let's try another one that you're going to do on your own. All right, so here's another one. What is the equation of the line tangent to h of x, where x is equal to negative 3? Why don't you pause the video and try this one on your own? All right, so if you did this correctly, we already have the x value. Our x value is negative 3. Our y value is the output value of h of x, where x is equal to negative 3, which is negative 6. And our slope is the output value of h prime of x, the derivative of h, when x is equal to negative 3, which is negative 12. And therefore, the equation of our line is going to be y minus negative 6, which is y plus 6, is equal to the slope, negative 12, times x minus negative 3, which would become x plus 3. And so this is the equation of the line tangent to h of x, where x is equal to negative 3. Okay. Now I want to do a couple more situations that are sort of that could throw you off in writing the equations, and they usually involve zeros. Okay, so here's another one. It says, what is the equation of the line tangent to f of x, where x is equal to 2? Okay, all right, well, we know how to do this. We've got our x value, x is equal to 2. Now we need an output value for f of x, where x is equal to 2. So here's f of x. Let's go over to 2. Output value is negative 6, so that means that the y value is negative 6. And now we just need a slope. Okay, so slope, that's f prime of x, where x is equal to 2, and we can see that the output is 0. So the slope is 0. Well, this is going to cause something very interesting, because what does it mean for a line to have a slope of 0? We know that when a line has a positive slope, it's upward sloping, and we know that when a line has a negative slope, it is downward sloping. Well, what does it mean to have a slope of 0? Well, to have a slope of 0 means that it is a horizontal line. And when it's a tangent line that is horizontal, it has a special name. It's called a horizontal tangent. Okay? Horizontal tangents are very important in the study of calculus, because horizontal tangent lines indicate an important place called a critical value on a function. Okay? And so what this has revealed to us is a horizontal tangent line. So let's go ahead and write out the equation. We know that it's going to be y minus negative 6, which would be y plus 6, is equal to the slope 0 times x minus 2, right? Well, here's the interesting thing, though. What is 0 times x minus 2? If you multiply 0 times x minus 2, that's just going to be 0. Therefore, the slope of 0 always cancels out the x term. And what we have now is y plus 6 is equal to 0. And if we subtract 6 from both sides, we wind up with an equation of the line that says y is equal to negative 6. So the equation of the line tangent to f of x, where x is equal to 2, is just simply y equals negative 6. Well, what does the line y equals negative 6 look like? Well, anytime you have a line that just says y equals a number, that's called a constant. Okay? It is a constant line, or a constant value. And so if we were to draw a coordinate plane, let's draw a y-axis and an x-axis. Okay, y and x. Let's go down 1, 2, 3, 4, 5, 6. Let's go, and then there's negative 7. If this is, so this is negative 5, this is negative 6, and this is negative 7, right? Well, this is a horizontal line at negative 6. So we can just draw a horizontal line straight through negative 6, and that is the line y equals negative 6. So anytime you see y is equal to just a number, that is a horizontal line, and it's called a horizontal tangent line if you know that it is a line tangent to the graph of a function, okay? All right, let's do another one of those. I just realized we can't do another one of them because if you look at all of it has to be a situation where a derivative is equal to 0. And if you look at h prime of x, we don't have any places where the derivative is equal to 0. And if you look at g prime of x, we don't have anywhere where the derivative is equal to 0. And if we look at f prime of x, there's only that one place where the derivative is equal to 0, and we already did that, okay? All right, so be cautious about that. Anytime you have a situation where the derivative is equal to 0, that means that there is a horizontal tangent line. And we're going to talk later in the semester about what that means for the graph. Typically, it means that the graph is either experiencing a maximum point, a minimum point, or a special inflection, a special kind of what's called an inflection point, okay? All right. I think that's it. I think you're in pretty good shape now. You should be able to write the equation of a line. Actually, you know what? Let's do one more. Let's do one where the x value is equal to 0 and another one where the y value is equal to 0. All right, here's one. Why don't you try it? Okay, we got what is the equation of the line tangent to g of x where x is equal to 4. Pause the video and try it on your own. All right, so let's see how you did. We've got x is equal to 4. Now we need the output value on g of x where x is equal to 4, which is 0. So when x is equal to 4, y is equal to 0. And now we just need the slope. So we need to go find where g prime of x is, where x is equal to 4 on g prime of x. So that's g prime of 4. Here's g prime of 4 is -1. Okay? And so now we're going to write it out. We're going to do y minus 0 is equal to -1 times x minus 4. Okay? So anytime you have y minus 0, basically you can just eliminate the 0 because y minus 0 is just equal to y. So we can just say y is equal to, and whenever you have a -1 as the slope, you basically can just get rid of the 1 and just make it negative this thing. So negative x minus 4. And also, since we don't have a term over here, you know, it's just y is equal to, we could distribute the negative to the x and the -4, and it would become y is equal to -x, and then negative distributed to -4 would become +4. And so we wind up with y is equal to -x plus 4. And now this actually is no longer in point-slope form, although technically it kind of is. This is now slope-intercept form, okay? All right, let's do just one more example. All right, here's our last example. What is the equation of the line tangent to h of x where x is equal to 0? Why don't you pause the video and try this one on your own. All right, so when x is equal to 0, the output value, the y value, is going to be whatever h of 0 is, right? So h of x, when we plug 0 in for x, so here's h of x. Let's go over to 0, okay? And the output value is 9. So h of 0 is equal to 9. That means the y value is 9. Now we need the slope, and the slope is whatever the derivative of h of x is, which is h prime of x when x is equal to 0. So h prime of x, whenever x is equal to 0, is -2, right here, okay? So slope is -2. So now we're going to do y minus 9 is equal to -2 times x minus 0. Well, x minus 0 is just x. And so what we can do is we can just do y minus 9 is equal to -2 times x. But since x is the only thing in the parentheses, we actually don't need the parentheses, and we can just have -2x. So y minus 9 is equal to -2x. Okay? And so here's your point slope form when x is equal to 0. But notice how easy it would be to now convert this into slope-intercept form. We can just add 9 on this side and add 9 on this side, and that's going to cancel the -9 over here, and we would just have y is equal to -2x plus 9. So this would be your slope-intercept form. Okay? All right, well, all I wanted to do in this little video is just basically show you how to write the equation of a tangent line or a line tangent to a function when you're already given something like the information in megatable. Okay, so now we're going to continue with learning about tangent lines.